All right, we are going to be looking at lesson 4.2, which we're going to be solving quadratic equations using the square root method. So to solve an equation by square rooting, we really just need to first get the squared value alone. So we are isolating the variable or getting it alone. And then we want to square root both sides of the equation. So we're going to take the square root on both sides of the equation because square roots cancel out squares. Make sure when you do that that you use a plus and a minus sign, that plus or minus symbol, because that indicates that we can actually have two possible answers for this quadratic. And then you will just continue to solve the remaining equation. I would recommend that you, every time you see a squared, that you kind of highlight it and go, okay, this is the thing I'm going to get by itself. So in the example that we have right here, if I were going to try to get that x squared by itself, the first thing I would need to do would be to take away 5 from both sides. So that would leave me 2x squared and then just 32. And then I could divide both sides by 2 because I'm still trying to get that squared value alone. And then once the squared value is by itself, now I can go in and square root both sides. And the square and square root will cancel each other out. And then whenever I put that square root in, I need to put a plus or a minus. We know the square root of 16 is 4, and so we get that x could be positive 4 or negative 4. Okay. So this problem is nearly exactly the same. I have this x squared term right here that I want to get by itself, and so the first thing I'm going to do to get it by itself is add 18 to both sides. And so when I add 18 to each side, I still have that 3x squared, but now I have equals 60. Then I'm going to divide both sides by 3 because I'm trying to get that squared by itself. And then once I have that squared term completely alone, that's when I can square root both sides. Squares and square roots cancel each other out, so that leaves the x by itself. I always put a plus or minus when I put a square root in there, so I have plus or minus the square root of 20. Well, on the previous slide, our square root was 16, which is a perfect number, and so we knew the square root was 4. Notice here it does ask for our answers to be exact, though, so that means I can't go grab a calculator, type it in, and get a decimal. It means we have to go back to chapter 2 and actually remember how to break down a radical. So we look for what perfect number goes into 20, which is 4, and then how many times? It goes in 5 times, and so our x is actually plus or minus the square root of 4 is 2. I don't know the square root of 5, so I leave that. So the exact answer for what x equals is plus or minus 2 root 5. Next problem, very similar, but you're going to notice one difference in this problem as we work through it. So I still start by adding 6 to both sides. I get 1/3 x squared equals negative 18 and 6 is negative 12. Remember, to get rid of a fraction, the easiest way to do that is to multiply by the reciprocal. So I'm going to multiply both sides by 3. That cancels out my fraction and gives me x squared. And then negative 12 times 3 is negative 36. And we just talked about last time in 4.1 that when I square root, we used to say, oh, we can't square root negative numbers. So we used to say no solutions. But now we know, plus or minus, that I can actually take the square root of a negative number if I put an I with it. Since 36 is perfect, the square root of 36 is 6. But then because it was negative, our answers are actually plus or minus 6i. Because I is what we get when we break down that 36 into a negative 1 and a 36. The square root of 36 is 6. The square root of negative 1 is I. And so that's how we get the 6i. All right. This one doesn't exactly look like the same format, but the steps are the same. But remember I said earlier, it's a good idea to look at what your squared value is. That's the thing that you're trying to isolate. So in this case, I have a whole quantity, x minus 4, that is being squared. So the first thing I want to do is try to get that by itself. So to get that by itself, I'm going to add 5 to both sides. And that's going to give me 12. But now that x minus 4, that is part of what's being squared. So I cannot try to get rid of that minus 4. That minus 4 is being squared. So since the squared thing is by itself, I can square root both sides. And when I square root the squared side, they cancel each other out. And that just leaves me x minus 4. Remember, when I square root the 12, I need to do plus or minus the square root of 12. And then we've got two options about what order to do this in. We need to get the x by itself, so we could say we're going to go ahead and add 4 to both sides. Unfortunately, I can't really add 4 onto a square root of 12, so I personally like to leave that 4 in the front and say there is 4, and then there's the plus or minus root 12. But the 12 is not simple enough, so we do still want to break that radical down. 4 goes into 12 3 times, and because 4 is perfect, it comes out of the radical as a 2 root 3, and then we just leave that 4 plus or minus. Please do not try to add the 4 and the 2 together. That 2 is being multiplied by a 3. If I had 4 plus 2x, we could not add that together and make it 6x. So same thing here. If I have 4 plus 2 root 3's, I cannot add that 4 and 2. I just leave it as 4 plus or minus 2 root 3. Okay. Right, so similarly here, I'm going to see what is being squared. This is what I want to get by itself. So in order to get that by itself, we're using the same couple of steps over and over here. We're going to take away 21 from both sides. So I have 3, and then there's the 2x minus 3 is being squared, equals, what is that, 75. And then we want to still work on getting that squared thing alone. The 3 is not part of what's being squared, so we have to get rid of that 3. And now all that is left is the thing that's being squared. The 2x minus 3 is what's being squared. Once we are down to that point, that's when we're allowed to square root both sides. And remember, when we square root, the squares and square roots cancel. That leaves us 2x minus 3. On the other side, when I square root, I need plus or minus. In this case, since 25 is a perfect square, I'm just going to go straight to writing it as plus or minus 5. But if you remember back on the first slide, we said that the last step is you have to get x by itself. So I still need to add 3 to both sides. Now here's where some people might find it helpful to write a second equation, because that plus or minus 5 actually means we're going to do 3 plus 5, and it means we're going to do 3 minus 5. So you might want to think of this as 2 separate equations. So 3 plus 5 would be 8, 3 minus 5 would be negative 2. And then that gives us 2x equals both of those numbers, 8 or negative 2. And so then we want to divide both sides by 2. So again, up here we could divide by 2, and here we could also divide by 2. And so we get 2 answers. X could be 4, or x could be negative 1. Every time we solve a quadratic, we will get 2 answers. It's just sometimes those might be written as plus or minus something. That's a positive answer and a negative answer. Sometimes that plus or minus can be simplified into two separate numbers. All right, I think last one like this. Yes, last one like this before we kind of switch gears a little bit. Again, look for what's being squared. That's what you have to isolate. So we're going to isolate this one by subtracting 4 from both sides, which gives us -10. Remember, again, to get rid of a fraction, we want to multiply by its reciprocal on both sides. So I'm going to multiply by 2 on both sides. That gets me x plus 8 squared equals -20. And then, even though there's still that plus 8, it is part of what's being squared. So once the squared thing is by itself, that's when we square root both sides. Squares and square roots cancel each other out. Sorry about that extra line. And then whenever we do a square root, we do plus or minus. I have the square root of -20, which means I need to simplify that. The last time we had a problem like this, I went ahead and subtracted the term from the left first. In this case, I'm going to simplify my radical first. It really doesn't matter which one you do first. So I'm going to think that -20 is really -4 times 5. And I know the square root of -4 is 2i, but I don't know the square root of 5. So I have plus or minus 2i root 5 equals the x plus 8. But x has to be by itself, so I want to take away 8 from both sides. And again, when I take away 8 from both sides, I can't really take the 8 away from that whole big ugly mess. So I like to write it up front. -8 is just the first thing I have, plus or minus 2i root 5. And that is your answer there. All right. So far, every problem that we have solved has had an x that is squared, and we can just square root it. There's nothing else in the problem that is a regular x. Every x that we've seen has been squared. But sometimes we're going to have a trinomial. Well, a trinomial will usually have an x term in it, and then some other number, something like that. When we have that extra x term in there, we can't just use that square root rule unless we do something called completing the square. So this is a process that we use to turn a trinomial into what we call a perfect square binomial. In other words, we're going to turn it into some x value plus or minus something squared. And again, the reason we need it is we're not always going to be able to factor trinomials as much as you guys have practiced. So this will allow you to turn the trinomial into something that we can then take the square root of. Okay? So here's how we're going to do that. First step is we are going to get the x and the x squared alone on one side. Okay, so if I were doing this example here, I would leave the x squared and the 4x on this side, and then I would move that 28 to the other side. So I would actually add 28 to both sides so that the 28 is out of the way of the x's. I only want to deal with the x's. Okay. If our leading coefficient is not 1, we take it out like we would take out a GCF. So the leading coefficient is referring to if there's a number here in front of the x squared. We're not going to deal with that a whole lot in Algebra 2, but if there was a number there, we would factor it out. Okay. So then what we're going to do to complete the square is we're going to divide what we call the b value in half. If you remember in Algebra 1 talking about quadratics, you had an ax squared, a bx, and a c. So the b is this middle term here. That's the one we are referring to, that we are going to divide that value by 2. We're going to cut it in half, and then we're going to square that value and add that value to both sides. Okay, so that sounds like a lot, but really it doesn't end up being a whole huge deal. What we're going to do is our b value in this case is the 4. So I'm going to take the 4, cut it in half. So 4 cut in half is just 2. And then I'm going to square that value. Well, 2 squared is 4. So whatever that value is, we're going to take that value right there and we're going to add it to both sides of our equation. So I am going to try to switch colors here. It's not going to work for me. Nope. Okay. We will add 4 onto this side of the equation. And to be fair in algebra, whatever we do to one side, we have to do to the other. So we added 4 to both sides. So now we have this equation that says x squared plus 4x plus 4 equals really 32. And so what we're going to do is factor the left side of the equation. Now, some of you might groan when you think of factoring, but the good news is because of the number that we chose that perfect 4, what is always going to happen when we factor that is we're going to start with an x and an x, and then we need to think of something that multiplies to be 4 and adds up to be 4. In this case, it's 2 and 2. But what you will find every time we do this is that these two groups are always going to be exactly the same. These two parentheses are going to be exactly the same, which means another way of writing it would just be, I'm going to skip down to the bottom here and write it as x plus 2 squared. Because there's 2 of them, they're exactly the same. I'm going to say, hey, it's an x plus 2 and another x plus 2. That's x plus 2 squared. And it equals, we add the 28 and the 4 together, and we get 32. And now this problem that we have here looks exactly like everything else we've done. So we can solve by square rooting. I'll just say solve by square roots. So at this point, we are completely back to what we have been doing. We can square root both sides. Squares and square roots cancel out. I get x plus 2 equals plus or minus root 32. And then we just break that down, 16 and 2. So we get plus or minus 4 root 2. And then x isn't by itself yet. We take away 2 from both sides. And again, we cannot take away that 2 from a radical, so it's better to write it up front, negative 2 plus or minus 4 root 2. Okay. So that was a little choppy with having us doing the writing of the steps in between. So let's actually look at a couple more like that where we don't have to come back and fill in all the words. Okay. Oh, actually, before we do that, I forgot about these slides. This is just saying what would the value be that we would add here. I don't love having a C written there because I think it confuses people. So I would just scratch that off if I were you and leave a blank. And really what they want to know when it says find a C value, they want to know what is that value that we could put at the end that would make this something that is a perfect square. So the way we figure that out is just by doing this step 3 right here. Divide the b value in half and then square it. So my b value is negative 4. I'm going to divide it in half. That's negative 2. But if I square a negative number, I get a positive number. So negative 2 squared is 4. That's the C value that they're talking about. And the way I can rewrite that then is if I wanted to, I could put my parentheses and go, what would multiply to give me 4, but add up to give me negative 4? Well, they must be a couple of 2's, and oh, it's a negative there, so they must both be negative 2's. Remember, we said they're always going to be exactly the same. So if they are exactly the same, that means we have a minus in both. So let's look at that again. This time I want to know what could I put here instead of having the letter C? What number could I actually put there so that if I factored it, it would be something times itself? So to do that, we take the 12, we cut it in half, that's 6, and we take that 6 and square it. And that's 36. That's the value that should have been in there for C. And the reason that value is so perfect is because now I can go, I wonder what multiplies to be 36 and adds up to be 12. Well, it must be 6 and 6. And so my answer is x plus 6 squared. So here's a little hint. If you're listening and paying close attention, listen now. This value that I got right here when I divided by 2, that is always going to be what's right here. If you look back at the previous slide, when we divided by 2, we got -2. Hey, look, that's what's in the parentheses here. It's going to be the same every time. If I made up a new problem and I said, hey, what could I put at the end and what would this factor into? I could say, well, half of 8 is 4, and 4 squared is 16. The 16 is what we would put at the end, and then this value here of 4, that's what's going to go in the parentheses down here. So this value at the top matches this value right here. Okay, so we'll see that as we go here. If I ask you to solve this problem by completing the square, our steps are, remember, we move the extra number to the other side because we want the x stuff to be alone on one side. And I always leave a little space there so that I can put in that number that I'm missing. Now, to get that missing number, we said we would take our b value, which is -6, and we would divide by 2, which is -3, and then we would square it. Remember, when we square a number, it's always positive. So that 9 is what I'm going to add onto both sides. I'm going to put a 9 in here, and I'm going to put a 9 on the other side, because we have to be fair in algebra. If I do something to one side, I do it to the other as well. Now I know, without going through the long factoring process, I know that what's going to go in this parenthesis is just this value right here. So in this case, what's going to go right here is going to match. That's going to be -3. And then I can add my 15 and 9 and get 24. And at this point, the process is the same as what we started the hour with. Square root both sides, squares and square roots cancel. Whenever I square root, I put a plus or minus, and then we would finish the problem off by simplifying the radical. What goes into 24 would be 4 goes in 6 times, which is 2 root 6. Don't forget that plus or minus. And then I'm going to be a little lazy here and say to get x by itself, I would add 3. Well, if I add 3 to the left, I have to add 3 to the right. I'm just going to add that 3 right in front and say I just added that 3 over to that side. So I have 3 plus or minus 2 root 6. All right. Let's try another one. I'm going to take away 25 from both sides because remember I want to get the x squared by itself with the 8x. Sometimes I even put a space there to say, oh yeah, I'm going to put a new number in there. But right now it equals -25. And then to figure out what's going to go on that blank, I take the 8, divide it by 2 is 4. We're squaring that value and getting 16. That 16 is what we're going to add here, and to be fair, we add it to the other side as well. Now, by writing that 16 in there, I now have a perfectly factorable term, and it's going to end up being, remember, this value is what's going to go right here. And so we have x plus 4, and then -25 plus 16 is -9. and complete our process the same way that we've been doing all along. When I square root, I need a plus or minus. I know the square root of -9 is 3i, and then I can just subtract 4 from both sides. Remember that 4 that we're subtracting, though, can't really combine, so I'm just going to put -4 plus or minus 3i, and we get our answer. All right, I'm going to work through this one really quickly. If you really feel like you get it, you might want to move on, but if you feel like I would like to see another example, feel free. So we've got this same process every time. I'm going to move that 24 over so that it's out of my way. I'm going to take that -14 and divide it by 2, which gives me -7. Squared, a negative number squared is always positive. So I'm going to add 49 to this side and add 49 to this side. Adding the 49 makes it perfect so that I can take this -7 and put it down here. When I factor, it's going to be x minus 7 in the parentheses. -24 and 49 is 25. And I square root both sides. Squares and square roots cancel, leaving me x minus 7. Whenever I square root, I get plus or minus. The square root of 25 is 5. And then I can add 7 to both sides. Again, this is one of those cases where it might be helpful to write two separate equations, 7 plus 5 and 7 minus 5. 7 plus 5 is 12. 7 minus 5 is 2. And so we actually get two separate answers. Okay. This last one, I think last one, right? Yep, this last one is a challenge. You might put a little star by this. This would be a bonus if we give it to you on a test or something like that. But we still start the process the same way. But the reason I know this one is a little more complicated is because of that 2 that's out in front. And remember we said in the notes at the beginning that if there was a number in front, we factor that out like it's a GCF. And so we actually end up with this instead. We take that 2 out. So then our process seems the same. We're going to do -4, divide it by 2 is -2. Square that value gives us 4. But then when we come over here and we add 4 to this side, we don't add 4 to the other side. And the reason is this 4 right here is in a parenthesis that is being multiplied by 2, which means even though we wrote +4, we really added a total value of 8 onto this side. Because that 4 is being multiplied by 2, it's like we added 8 onto this side. And so we actually have to add 8 onto the other side. The rest of the process stays pretty much the same. Whatever we had over here is still going to go in my parenthesis down here, which is a -2 squared. And then -12 plus 8 is -4. Remember, though, at the beginning of the notes, to get this, before we can square root, we have to get the squared part alone. So I have to divide by that 2 to get this alone. And then I can square root both sides. And when I square root, I plus or minus. I actually cannot take the square root of a -2 because 2 can't be made any simpler, but we don't like negatives under square roots. So if you think of that as it's a -1 times a 2, I know the square root of -1 is I. So whenever we have just a negative in there and we can't do anything else, we at least can take out the I and leave the root 2. And then we want to add 2 to both sides. And so our final answer for that is x equals 2 plus or minus I root 2. Lovely answer, isn't it? So that is how we are going to solve by square rooting and also completing the square. So good luck, and let us know if you have any questions.